let's get started. We're doing Solidity in depth today. We're going to cover the Solidity environment, data types and memory management, data structures, additional syntax, and external contract calls. So, the Solidity environment. When you're developing a DApp, or when you're developing an app, a centralized app, you usually use one of these frameworks to do that, and you use an MVC model, right? Model view controller, where you set up things in a hierarchy just for ease of use, things like that. There's the equivalent of that with dapps. The framework here is called Truffle, and that's what's going to be making your lives a lot easier. It basically takes care of things like boilerplate code and setting up a front end and running. It abstracts all that away into a couple of simple commands. We also use test RPC, which mimics kind of a mock blockchain on your local desktop computer, right? So you can just run test RPC, and boom, you have your own mini blockchain running where you're able to deploy transactions, contracts, things like that. You're able to migrate changes. It simulates full client behavior, and it makes developing on the Ethereum platform a hell of a lot easier. Okay, so after you've got test RPC up and running, you want to run truffle init in a new directory. And just like things like git init, it just instantiates your working directory, right? So it'll set up your hierarchy, which looks like this. You'll have a contract directory, which is where obviously you'll put all your source code. You'll have a migrations directory, where you'll add scripts for migrations. Now, what are migrations? Can anybody tell from like working on X1 over the past week?
JavaScript.
Sort of, yes. But what's the purpose of that? Yeah, getting closer. Right, so say you want to update your contract, right? Instead of having to take it down and then uploading a new contract, because remember, you can't make changes to the blockchain, you run a migration, which layers a change on top of your contract. So in real life, that kind of parallels what you would do with deployments, where you can set up new deployments over time, and then if something is buggy, you roll back to a previous deployment. In this case, you have migration scripts, numbered 1, 2, 3, 4, and they run in order. And there's an initial script, which is instantiated when you do a truffle init, and that initial script deploys a starter migration contract that then subsequently keeps track of every migration script after it, if that makes sense. Finally, you'll have your testing directory where you're going to check for vulnerabilities. So just to show you guys real quick what we mean by that. This is the demo we're going to be doing today, and you've got your contract directory, your migrations, and your tests, right? And so your migrations look like this. They should just be simple 3 or 4 liners, just saying, okay, adoption is my contract. I'm just going to deploy it, and that's it. And so you'll have 3, 4, 5, 6 migration scripts like this, and you'll notice this is written in JavaScript, not in Solidity. Right. This is the contract we're going to be working with today. We're not going to do anything specific with it. We're just going to run some tests, and I'm going to show you how to do that. It's just the adoption contract from the Truffle examples, or Truffle boxes, if you guys are familiar with that. So Truffle comes with its own templates that you can download for front-end things, for local testing, and so this is just one of them. And then this is what our tests look like. This is what a test written in native Solidity looks like. We recommend not writing your tests in Solidity, just because with JavaScript, you can afford to send from other transactions, you can afford to send any amount of Ether, and that makes it a lot easier to handle. Whereas with Solidity, you can only run contract methods from said contract and not externally. That being said, Solidity is fine for what we want to do today. And so I have here, okay. I hope you can see that. So I'm in my console right now, and I'm in the directory. So let me just cd into pet shop demos. Okay, and now what I want to do is after I've truffle init and uploaded all my source code or written up tests, things like that, I want to run truffle compile. And what truffle compile does is it compiles all your Solidity, which is a high-level language, like Python, for example, down into the EVM bytecode, right? So the machine can read it. After that, I want to run truffle migrations. Oh, truffle migrate. And what this will do is it will run all of your migration scripts, right? If there are no updates to the migration scripts, then it'll just do nothing. Because all your migration scripts have already been run, and the initial contract keeps track of the latest migration, right? And so it seems to be still doing that. Yeah, this could take a while, depending on how many scripts you've got running. Yes? What is truffle deploy? Okay. Have you seen that command being used? Okay. Right. So, yeah. We try not to use deprecated methods, so truffle migrate is the latest one you should be using. No idea why it's taking so long. Oh, yeah, true. Thanks for pointing that out to me. We got to test RPC. So we've migrated, and there should be a new build directory that gets set up in your working directory. And then you can run truffle test. And yeah, and that should run your tests with a bunch of warnings. Okay, so we got 3 passing tests, and as you can see, we had written 3 tests previously, so that's fine. That's how you run your tests. And if that issue comes up, well, now you know how to fix it. Okay, any questions on that? Yeah, so as mentioned earlier, in Solidity, it just makes it easier to write in native Solidity because you're used to it. There's not much, like, in terms of syntax. But with JavaScript, it allows you more flexibility. So it really depends on your needs. If you want to do something on the fly, use Solidity, that's fine. If you want to be able to specify external contract calls, JavaScript is what you want. Yeah. Any questions on the commands and what they do? This is basically your lifeline. This is what you're going to be running. Maybe you want to alias it as well. Right. Okay. So now moving on to data types and memory management. A word on memory management. So memory management in Solidity is strange. You would think that when you instantiate, for example, an int of a bigger size, then that would take up more gas, right? That's not the case, actually. So when you instantiate a uint of 256, that's actually cheaper than instantiating an int of 8 bytes, for example. The reason for that is that it takes gas to downsize because every data type is in 32 bytes, right? Yeah. The other thing is that there's this concept of tightly packed memory. And what that means is at the very bottom it specifies that if you instantiate 2 uint 128s and then a uint 256, that's much more memory efficient than instantiating a uint 128 and then a uint 256 and then again a uint 128. The reason for that is that Solidity tries to package similar data types together in one unit, right? And if you have this switching going on, that means that it has to package them in 3 different units as opposed to just 2 in the previous example. Now, what's interesting to note is that if you're doing this in structs, then gas costs work as you'd expect them to work. So uint 256 does take up more gas than a uint 8, but only in structs. Okay, any questions on that?
Would a uint 8, like would does a struct make it take more gas than how would if it weren't a struct?
So this for uint 8, oh, then if it weren't a struct.
Like a uint 8
Yeah.
inside a struct would be
Yeah.
less than a uint 8.
Exactly.
Okay.
Less gas inside a struct because it would work as you'd expect. Actually, relative to outside, maybe everything takes more gas, maybe even uint 256s. I'm not entirely sure on that. I just know that internally it works as expected. Okay. So with data types, we're talking about uints, ints, 256, things like that. Some of you might not know what those mean if you haven't taken CS61C, for example. Does anyone know the difference between, say, an int and a uint? Right, right. What does it mean to be unsigned?
Unsigned means you only have positive.
Exactly. So a uint means that you can only represent positive integers. And what that means, what would you use a uint for? So following on from that, yep.
Like an address or
Like an address where you will never have a negative value, or like a time date, right? Where you'll have September 19th, right? That'll never be a negative value. And that's what you would use a uint for. In almost every other case, you might want an int. And then what does the number mean? 8, 16, 32. Yeah, yeah. Does that make sense? And so the amount of bits or bytes you allocate to a certain data type, the greater the number you can represent. So uint 256 can represent greater numbers, right?
what would the size be required for an address?
An address is 160 bits. Yeah. So, but address is its own data type. We'll see that in a bit. Okay. Yeah. So we have this concept of overflow as well, and I think there's a demo, right? Yeah. Okay. Whoa. Okay. So I'm gonna go up to I'm gonna uncomment these two. Okay. Can anyone tell me why they error? So this is in Remix. Maybe I should zoom in a little bit. Does anyone know why they error? There's two X's right there. Yeah. Mm-hmm. Yeah. So uint 8 can only store up to 255. So naturally, if you try and do 256, can't do it, right? If I go ahead and create this contract, oh wait, I have to go ahead and comment these. Okay, now I can try creating these. So if I try and run this function right here, so hang on a second. Interesting. Okay, so for some reason the browser froze. Does anyone know what would happen if you tried to add 1 to C? Someone who hasn't answered yet.
Yeah, since 127 is like the highest on the positive side.
Right, it would become negative 128, and that's called an overflow, and that's actually a source of many attack vectors that you'd see in industry. So watch out when you're using signed or unsigned numbers, and depending on the size of the int you're assigning to it.
What if someone uses an 8 by 8-bit integer that costs more gas and raises the risk of overflow?
Good question. It really depends on the use case. I personally wouldn't use an int 8 for anything, but there are situations where you might need it. And Solidity allows for that flexibility of design choice. Okay. So in Solidity, you can cast data types. So if you have a string that says 1, like in quotations, you can cast that to an int, just like that. You have this thing called infer typing, which is where Solidity can just infer the type of the data based on how unique it is, right? So, for example, true and false are obviously Boolean, so Solidity can understand that. And then you have addresses, which are these 160-bit strings of numbers and letters. And for addresses, the only operations you can do are things like send, things like transfer. You can check for equality. So if an address equals or is greater than less than another address. So when you're choosing to do something like send, the send can fail. And when it fails, it will return a false. And usually, convention states that when you're doing that, you use it in an if statement so that you can return someone's value if the send has failed. Any questions on that so far?
Yeah, so if you're infer typing and you have some kind of integer like var 8 equals 15, what kind of int does it think it is?
Var 8 equals 15.
Yeah, var A.
Var A
Yeah.
equals 15. So I think the int defaults to uint 256. At least when you state just int by itself, it defaults to int 256, or if you state uint by itself, it would default to uint 256. I assume that's what would happen there. Okay, any other questions? Right. One thing to note is that another vector of attack with these sorts of things is where you're not checking whether send failed or succeeded. And when you're also sending someone their money before deducting how much they have on the contract, right? So you always want to deduct first. If you look at the at banking contracts, for example, you'll always see that they have a design pattern where you deduct first, then you check if the send succeeds in the if statement, because send itself, when you run it in the if statement, returns a Boolean, and then you continue with the function. Any questions on that? Okay. One thing to note for methods like transfer, send, etc., watch out. A contract writer can override those functions. And so when you try and call a send method, it might not do what you think it'll do. And contract writers can manipulate that to their advantage. Likewise, if you're a malicious actor, you can set up a contract with a different send method. And depending on the contract you're trying to query, you can start siphoning off funds from other contracts. So again, beware of that. These are the different types of methods you can call on addresses. What's the difference between send and transfer? Does anybody know?
Transfer will throw an error if it doesn't work.
Yeah, almost.
Throw an error which then reverse the whole.
Right, exactly. Yeah, there you go. So you want to be using transfer instead of send, because Booleans make you do more work. You have to do something with that Boolean, whereas with transfer, you want to be, it'll automatically handle the error cases for you. Okay, so we have these things called bytes, and bytes are exactly what they sound like. Yeah.
Wait, so it will automatically handle the error case for you? Do you need to be like catching, like try catch kind of thing?
No. So it'll automatically call revert, which will revert the state of the contract back to what it originally was. Okay, so with bytes, I'd recommend using bytes over strings in general, and you'll see why in a second. And so you can specify the amount of bytes that you want for that variable. So if you say bytes 2, you have 2 bytes for that variable. Bytes 32, which is the maximum, you have 32 bytes for that variable. If you just say bytes, then that's kind of an efficient data type, but also inefficient at the same time. It's more inefficient than saying bytes 2 or 3 or 4, because it instantiates a memory size equal to the maximum. But it's more efficient than a byte array because it's tightly packed, which goes back to that notion we were talking about earlier. Any questions? The main takeaway is that you should be using bytes 1 to 32 if possible, instead of just bytes in general. Unless you need it to be dynamic. If the byte size is going to be changing throughout your contract, then you can just use bytes. So in order of priority, it would be bytes numbered, bytes, and then byte array. Yes. Yes. Well, so it's progressionally like bigger. Like it takes up more memory, right? So byte 1 will take up less memory than byte 2. So only use really what you need. If you know the amount of bytes you'll need and that amount will never change, specify that amount. If you don't know the amount beforehand, just specify bytes. Okay. Oh, hey. If you need what, sorry, an array of strings, that'd be preferable. So the reason for that, that's a good question actually. Never use an array of strings, and we're getting onto strings right now. There's no flexibility with strings, and that might be a good thing because you don't want them to be mutable, right, in general. But Solidity does not allow for dynamically sized 2D arrays, right? So what that means is you need to set the memory allocation of 2D arrays. Not so with 1D arrays, but 2D arrays, that's the rules. No dynamic sizing. Now, where do strings come in? Well, strings themselves count as sort of like arrays. So if you have an array of strings, even though that's technically a one-dimensional array, in Solidity, it's a 2D array. So you can't have dynamic sizing there either, which is a problem. Any questions on that? Okay. In general, why else do strings suck, right? They're encoded in UTF-8, which is not memory efficient. You can't concatenate them. You can't splice them. You can't do the things you would normally be able to do with strings in Python. So for example, if you look at this string section right here, the way you concatenate is by running this big function right here, where you cast 1, which is a string 1, and 2, which is a string 2, into bytes. You'd create a new temporary variable, which is the size of the end result as a string, cast that into a byte, into concat, and then iterate through that halfway, assigning all of 1 into the first half, and then all of 2 into the second half, and then at the end that would return as a string. You'd have to recast it back into a string, and that would return 1, 2 concatenated into one word, so 1, 2. Okay, any questions on that? That is ridiculous. Yes?
So, are there not actually strings in the EVM, just Solidity putting a layer on top of bytes to make it seem like they're strings, but it doesn't actually give you like, all the string operations?
Good question. I don't think so. This is just me talking, because if that were true, why would they, if strings were built on top of bytes, why would they limit your flexibility? Because you could just do whatever you want to do with bytes.
Right.
So I'm not entirely sure, and I don't think the docs really touch on that either. But it's possible.
Wait, is this because strings are like character arrays, and when you compare strings?
Yeah, they're character arrays. Are you talking about the dynamic sizing for 2D arrays?
No, I'm just talking about like the reason why you can't concatenate.
Yeah. Okay, so that was the demo. What else? Okay, so with type inference, what you'd really want to be using it for is something like this, where you assign a function to a variable and then call it later on. You wouldn't really want to use it any other way. So, for example, for your question, you would want to specify what type of int you're using. You wouldn't want to say var and then a number, right? Same thing with the Boolean. You wouldn't want to say var a equals true. You'd want bool a equals true. Just to be as specific as possible, both for readability and convention, right? So by default, things like mappings instantiate values to 0. And then you can delete them to free up memory. So akin to if you've taken 61C, mallocing and then freeing that memory, you can call delete on certain aspects of the code. The thing with that is if you try to delete a mapping, which is, we'll get to that later, but it's basically a list of key value pairs, the delete won't work. If you try to delete a struct, then it'll delete everything in there except for mappings. So the Solidity docs say that with delete, they reset the value of the variable to 0. Now, that's been a strange point because there have been some tests where they instantiate a variable and then delete it and then try to access it, and it's not 0, it's just non-existent. So the docs are kind of strange in that sense, and perhaps they do mean that it does get deleted, but nobody really knows what's going on there. Yeah, but for now, just take it as it sets it to 0. Any questions on that?
So this is true with like all data types under the mapping, so like addresses and everything that's
Yeah, for the most part. And if it's if it's a data type containing multiple values, it'll recurse through those values and delete each one subsequently.
So that if you delete something and then you have like a statement like if it's all that will value.
It should. It should, yeah. And you can go ahead and test it. Okay, so data structures. Arrays. You definitely don't want to be using too many arrays, right? As you probably found out in your Fibonacci contract, if you try to do the extra credit, keeping track of multiple values or keeping track of multiple greetings for the greeter extra credit, arrays are difficult to work with. So just use mappings instead, which we'll get into later on. The way you instantiate a static array, which is an array with a set amount of elements, is just in the square brackets, specify how many elements you want. If you want it to be dynamically sized, do it that way, without the number. Okay. And you can get the length as you could in Python, etc., etc. Now, the reason we don't want to be using arrays is because arrays require us to loop through them sometimes. And loops are generally not considered a good practice in Solidity. Okay. What you want to be using is mappings, right? Mappings are basically like Python dictionaries where you have key value pairs. So you'll specify mapping A, so that's the mapping name. Mapping A, open bracket, animal. And animal might be a string or whatnot. And then you might map that to cat. Or a number. You can map one data type to another data type. So string to int. What you'll usually see happen is there'll be mappings called balances, where you'll map address to that address's value. So how much money that the person at that address holds on the contract. For example, banking contracts. And you can have nested mapping. So this is where you'd want to do your two-dimensional shenanigans, right? You don't want two-dimensional arrays, you want two-dimensional mappings. And then to delete, as I mentioned earlier, you can't call delete on like a single mapping, but you can call delete on a single key value, right? Because it's hard to determine beforehand what the key values are in the mapping. Okay, so structs. You probably saw these as well in your assignments. Structs are customizable data structures. You can specify each parameter in each one. As you can see here, you can specify a struct bank, you can call it anything, and that has an address and a uint, and that's it. You can add more in there. It doesn't have to be 2, it can be 3, 4, 5. Right, and there's various ways to instantiate that. And then deleting the struct, again, resets all values back to 0. Okay, so enums are kind of strange. Right.
So I'm just a little confused. You said delete was kind of the case for memory when that's like something
Right.
allocated memory. But in this case, you're saying that actually you're setting the value to 0.
Right.
So you're not actually bringing that memory.
So again, yeah, that's
Contract still using that previously allocated memory.
so it's not. It shouldn't be, right? But it's a point of contention whether or not it does get set to 0 or whether or not it does get deleted, like in real life, right?
Like what I mean is like, are your contracts still paying for using that memory even after it's been deleted?
Yeah, they shouldn't be. That's the idea of delete. Yeah. Okay, so enums. Who's used enums? Just in code in general. 1, 2, 3, 4, 5. Okay, not too many people, right? So even in real life, you don't see enums that much. And enums are used for, they're basically like structs, but for set values that maybe rotate, but they're set values. So, for example, a compass enum would only contain north, east, south, west. And you wouldn't put anything else in there. Okay, so we're halfway through. Take this time to sign in, ask any questions you have about anything covered so far.
Okay, I think you guys probably had enough time to look at the URL. You can also take a picture if you want to. But okay, so we're going to go into some additional syntax, and we have operators. These you don't really have to worry about. If you took 61C, great, you can use them. If you didn't, don't worry about them. We have global variables. You guys have already, some of you may have already interacted with this for the last time, and you probably did. So this is going to refer basically to the contract instance, and with this, basically you can access the contract balance. You can also call functions externally. With message, this is referring to the message received by the contract. So if you want to get attributes about that, you can. You can also get attributes about the transaction, which is usually referring to the initial transaction that people use for contracts. So remember the difference between a message and transaction? Do you guys know what the difference is? Well, they both change state. I didn't quite hear you. Can you speak up? Yes, exactly. So transaction often is going to start with a user or a user-based wallet, and that's going to go to a contract, or another wallet that's owned by a person, and basically a message is going to be internal. So transactions can also contain messages, which in a sense you can look at as internalized. So this goes to the contract. But when you call a transaction at origin, it's always going to be a person. So remember that. We also have some other global variables, such as block and storage. Storage is going to keep track of all your persistent variables, so you can access these using a hash. And block is just going to tell you information about the block you're on for the contract, wherever the contract is deployed. So if you want to get the difficulty or the hash of a given block, you can do stuff like that, and maybe even potentially do some random generation that way. We also have functions. So you guys have obviously seen these, but some things you can do, for example, you can have multiple arguments, but you can also implicitly return those arguments. So if you look at the second example of increment, we don't actually return x and y, but we stated it returns x and y in the function header. So you can implicitly return variables that way. And constant basically is going to indicate that you cannot change persistent variables inside a function. So note that we declare u and y here, and inside we try to increment it. However, this would fail because the function is declared as constant, and we cannot change state variables in a constant function. So you can only change local variables. So if it's outside the function, no, you can't. So we also have visibility attributes. You've seen this in other languages. Pretty self-explanatory. Public you can see externally and internally, which is the default for all functions. You want to be explicit in Solidity about your visibility so that it's extremely clear to whoever's looking at your code what the function, who has access to that function. External is only visible externally. Private is only visible in the current contract. And internal is visible in the current contract, but those deriving from it as well. And we will talk about inheritance, which is kind of relevant to that. You can also assign functions to variables. which is interesting. And you also don't want to use recursion in Solidity, mainly because the max call stack is 1024, but also because loops are much more easier to debug. You also have the fallback function, and this is called if whenever you call a function that doesn't like match like its header or its inputs, or if, for example, if you call a non-payable function but you try to pay to it, how do you get your money back from the contract? And usually, like, you'll have a fallback function in your contract that will revert, and that will send all the funds back to the person who sent those funds. You also have events, so you can like log. This is useful because if you want to access data outside of the contract, you can do this using the JavaScript API called Web3. We'll cover that 2 lectures from now, but basically here's like some JavaScript code that shows you how to access like events that you basically put in your code. We also have modifiers. These are good if you want to really be modular about how you do your, I guess, assertions. They're very similar to assertions in like Python. More similar to decorators actually, because you have like a conditional statement, and you write like a template function, and you see where the dash is. That's where like the function, like the function's like code goes for which you put the modifier on. So if you look here, wherever the dash is, for example, modifier check value, that's where like the function information will go, and you'll put the modifier like right after the function declaration. Does that make sense? Yeah. So basically, here. So notice that a modifier is basically going to have a conditional, and it's going to be like kind of a template. So if now is less than or equal to time, then we throw, and if that's not the case, then we continue the rest of the function. So then we place this modifier right under the function header, and if we don't throw, we go to the rest of the function logic that's happening in the function. Does that make sense? Yeah, you have to make them yourself. That's a good question. I'll go into like the differences, but basically, you don't want to use asserts in like modifiers. You usually want to use them at like the end of like your function. And usually in a modifier, you can template it, but at the end of the day, like asserts, you want to be very careful about where you put them. As for, you asked also about like require. Yeah, for require, you can use that instead of a throw, which is now what we use instead usually. They have the same like functionality as like a conditional and throw and revert and require. Those two have the same functionality. Yeah. Loops. So you don't really want to use these, mainly because your code can like stop in between if somebody doesn't put in enough gas. And when that happens, people can get some weird execution happening. So for example, if you have like some kind of piece of code that has value being subtracted from a wallet, and you want to like try to exploit that, and it's in a loop, you can like try to put enough gas so that the code execution stops there, and basically keep subtracting from that person's wallet. So that's like a very malicious way to take advantage of loops. We have another example here, which basically if a lot of people want to get refunds, and there's a giant list of people that want to get those refunds, the loop work is going to like keep going through that list, and if it fails when the gas exceeds, then people won't get their refunds. We also have external contracts. So these basically this is important because you want to be able to say access another library, or you want to be able to interact with another contract, and if you want to keep your code modular for some reason, you can point to another contract on the blockchain by referring to its address, and you can create a new instance of that and start using its functions. Inheritance, you guys know about this. Basically, you can import you can inherit other contracts, as it's almost like class inheritance. You can also override their functions using super, and you can also have abstract functions. So, for example, many of you have probably heard of the ERC20. The ERC20 is like a token standard that people use for ICOs. It has like certain methods that you have to follow. That's when you use an abstract, that's when you like make use of abstract functions from abstract contracts. We have imports. I think in particular where this is most useful is, say you don't want to have to write like string concatenation functions, or you don't want to have to you don't want to have to write like functions to iterate over a mapping. You can just like import someone else's library from like GitHub, which is really useful. So people can actually like live update code, interestingly enough, and that actually can be pretty useful if you want to like change code after it's been like deployed on the blockchain.
Doesn't an update while the function is what I call an error?
Can you repeat that?
Does an update to the code you're referencing GitHub and then while the function is running, that cause an error?
So I mean, once it's deployed, it'll usually like import, but after that, like during execution, everything is imported. So like if someone changes it during execution, it won't error out. But I mean, like somebody changes this to be faulty code, and then tries to execute, then it'll error normally. Yeah.
Isn't that a attack vector though? Can't you like place code that people have an implicit understanding about and then just make the new code send everything to your address?
Yeah, that's a good point. So yes, it is an attack vector, which is why you don't want to put anything like super valuable on that GitHub. Like you want to put very generic libraries that you import from GitHub that can be updated later on, in case like the EVM like updates or something. Okay. So there's revert, require, assert. These are all keywords. It's kind of confusing what they are at first, but I'll go slowly. So revert basically just means revert all changes that have happened and basically send back refunds to the person, whoever like paid to the contract initially, if they paid. And basically remember that all the gas that has been used in execution is going to be used. However, the remaining is going to be refunded in this case. So require is going to be used at the beginning of a function to ensure that you have valid conditions. This is much more frequently used than, say, assert. And assert is basically something that you don't usually want to hit in a contract. The reason is because you want to use it for internal errors and to stop things from happening. Nobody really like says why this is. Like, it's kind of just like a design decision by like the Ethereum Foundation to just say, okay, use assert whenever you have like internal errors in the contract. So an example of that would be you have integer overflow or underflow, or you have some ridiculous condition like that should never ever happen, like come true. Whereas assert you are going to use for much more frequent conditions. So that's not for like internal errors. That's for like external errors that happen. So if somebody's balance doesn't match, then that's when you can use an assert statement. Self-destruct. So basically, if you want to be able to destroy a contract after a certain amount of time, this will remove storage and code from like future blocks. So once you post things on a blockchain, it's actually always there. This technically just nulls all execution of this contract. It doesn't necessarily like delete it. So it's always there. You can't really like delete things off the blockchain, like it's immutable, right? One thing you might want to do is, you might want to delete your contract, but then your contract is an account, right? So you need to send all those funds. Basically, call the self-destruct you call the self-destruct function, and then you input like an address to the creator, usually, or some other address. So you can transfer it to another contract, you can transfer it to any other account on the blockchain. Some tips about storage. Storage is expensive because it is permanent, and things like multi-dimensional arrays are expensive because they take a lot of space. Usually you should store things off-chain unless you absolutely need to keep them on-chain. And blockchains are public, so everything like remains, even code that you self-destruct, it's still always there. You just can't execute it once you self-destruct. Another thing about time, so this is like pretty self-explanatory, but one main thing that you should note is that you should never use time for like a lottery contract or something that will affect like a condition that then ends up giving you value. That's because miners can basically mess with a timestamp, and they can mess with it in terms of seconds, but not like days or like longer periods of time, because that block will be rejected. But if they can mess with seconds, they can basically like keep trying to game your like contract until they get like a winning lottery ticket or something. Yeah.
Block hash.
Block hash. So for block hash, yeah, they can play around with that too. Yeah. Yeah, it would be. Yeah, it would be. So, yeah, some quick summary about style. Remember 4 spaces for indentation. You want 2 lines to separate contract declarations, and you want to avoid extraneous spaces and parentheses. This is pretty like standard stuff, honestly. You can also omit curly braces for one-line statements, so this is also done in JavaScript as well. And else should be placed on its own line always. Any questions? Yeah.
So when you calculate gas, how would we store it? And the other rules from the rules, like you put while true, things like that?
You can do while true, but you'll run out of gas. So that person will have to pay for that while true.
So there's no like restriction on how we.
Yeah, there's no restriction. The only restriction is how much gas you have and how much you're going to pay. Yeah.
So did they concern about running out of gas after a call is made?
Concern about running out of gas after the call is made to revert?
Yeah. I mean, like, is there some specified hours
There shouldn't be. Like, revert would, this is gas, right? So would there be an issue ever called revert and there was X number of things that were supposed to happen before the contract did or whatnot? But then we would run that and then in the middle of the process and all of that.
Sending the money back is taking gas.
Yeah, it doesn't take up any gas.
I think money, getting all the, and then constantly going to write it.
Oh, yeah, so,
What's up?
so,
Why Truffle doesn't like division?
Yeah, so like, what can you do is like,